to speak with everyone today. Today's topic is going to be about understanding the differences between qualitative and quantitative analysis. I have to say, looking at some of the folks who are here in our webinar today, we have some pretty senior folks in the audience, folks that both Anne-Marie and I've known for quite a while. So today, we're really giving you guys a nitty-gritty, meatier topic. So I think you're going to enjoy it. Feel free, put any questions you have in the Q&A, and let's get started. So this is just a background slide on AWS Solutions. We've been fortunate enough to win just about any award you could in analytics and in data literacy. And this is just a small list of client partners we've had since actually over 25 years. So a little crazy. This is just my background slide. I'm not going to go through this, but if you have a question for me, feel free. I put in my email address at the bottom of this slide. Feel free to shoot me an email. I'll do my best to answer your question. And also follow me on LinkedIn. I post articles and videos and different topics there when I have the chance in my ample spare time. So anyway, what am I? Anne-Marie laughed at that one. She knows I'm spread across so many different places now. Anyway, what am I going to talk about? I always think that, data literacy is such a hot topic. It's such a newer topic that I want to make sure to hit a little bit of fundamentals and background, just one slide on it. Then let's take a deep dive into qualitative and quantitative analysis. Then I'll talk about hypothesis testing and how this, because that's what you're using some of this type of analysis for. And then talk about correlation. If we have time to, because I have quite a few topics to get into. All right, buckle up, because here we go. We're going to go through the topics. So first up, when we talk about data literacy, what are we really talking about? We're talking really about two things. One is we're talking about how data literate an organization is. And a data literate organization has invested in things like data governance, metadata management. They have good data science. They have a CDO position and a host of other things. The definition I'm giving you on this slide talks about data literacy at the individual level. And when we talk about an individual being data literate, it's really about their ability to create, manage, read, work with, and analyze data to ensure and maximize its accuracy, trust, and value to the organization. Really, again, looking at our audience today, we have a lot of longtime data management professionals. That's what we've been doing from the beginning, trying to maximize our data's accuracy, trust, and its value to our organization. So let's get into, now that we have just a little bit of background on data literacy, I told you it would be quick, qualitative versus quantitative analysis. So let's talk about it. So first up, as you hear this topic, you may have bad flashbacks to your days in college when you had that horrendously difficult math class, the one you just skated by. Or if you're like Anne-Marie, you got an A in it because she got an A in all of her classes. And, Anne-Marie is like the curve breaker. So if you have Anne-Marie in your class, you need to swap classes because you're going to wreck that curve for you. So anyway, you remember those people. Anyway, I do. I love the curve. It always helped me. Anyway, so when you look at these two things, qualitative and quantitative analysis, I'm hoping it doesn't bring back some bad college nightmares or high school nightmares, because really it's not that complex, and I'm going to make it a whole lot simpler for us than it ever was for me when I was in college. So when we talk about something being qualitative, it means the characteristics or the categories can't be measured numerically. There's no way to count what it is. And so if I ask Anne-Marie, may I ask what you had for breakfast?
Yes, you may.
What'd you have for breakfast?
I had an egg, a glass of orange juice, and a cup of decaf tea.
Okay. Anne-Marie, did you enjoy that breakfast?
Yes, I did. Oh, and a piece of whole wheat toast.
Okay. So the question I just asked her, did you enjoy the breakfast? It can't be measured. There's no numerical number. I asked her opinion. So it's a good example of a qualitative measurement. I can't measure it. So if somebody else says the exact same thing about their breakfast, it could turn out that that other person was really ecstatic about their breakfast, but they use the same terminology. There's not a measurement. If I ask Anne-Marie how tall she is, that's an example of quantitative. We can measure it. And if you look here, I have a little cheat sheet image on this slide. When we look at the names of people, when you look at name, gender, favorite food, these are qualitative. You can't count names. We don't assign the name David a 1 and the name Elizabeth a 2. That's not how this is done. Those are qualitative. Where something like age or height, that's something that's quantitative. We can measure it numerically and we can aggregate it. So we can add those. So we could, in this list of 4 people, add everybody's height, divide by 4, and get the average height for this group of individuals. So high-level overview, quantitative, qualitative. Quantitative, think quantity, you can count it. Qualitative, think quality, something that you can't count. You can't measure it numerically. All right, qualitative. Let's dive into this. This is the more complex of the two. I don't know why, but I'm going to go after the more difficult one to begin with.
Because
but again,
you just would.
Anne-Marie, we've worked together for 2 decades. You know that. Why not? We get the hard one out of the way, and then the second one will be a little bit easier.
Yes.
Maybe that's my subconscious logic in this. But anyway, while qualitative analyses, when you're doing qualitative analyses, you have 2 types of variables that we're dealing with in an analytic: nominal and ordinal. Wow, nominal, ordinal, I'm lost. Oh, I give up. That's too complex. Those are big words. You need letters at the end of your name to understand those, but not really. Think, when you hear the word nominal, think normal. When you hear the word ordinal, think there's an order. Of course, I'm going to show you more on this. So let's look at it. When we talk about a nominal qualitative variable, so if we need to build an analytic, and we realize, hey, this is going to be a qualitative analytic study. Maybe we want to ask people's satisfaction with their breakfast each morning, as I did with Dr. Smith. So if I want to do a nominal analysis, we're going to represent categories that cannot be ranked. Let me give an example. Possibly, let's say we're doing an analysis on vegetables like broccoli, spinach, and carrots. These are nominal qualitative variables because they're not ranked. Carrot is not a higher rank than spinach, although I think a carrot tastes personally. But
I'd rank broccoli first.
Anne-Marie would certainly rank broccoli number 1. But this is a good example of just, we can't rank these. If we're looking at an analysis of vegetables, broccoli, spinach, and carrot of themselves, there's not a ranking in those. Now, if we do something else, we can rank them, but of the variables themselves, there is. Remember, think of nominal as named. These are names of just normal things. So when you think nominal, think name. So if I want to do analysis on vegetables, I'm using nominal variables or named things. Pretty simple. All right, now ordinal. These are variables that can be ranked, but not numerically measured. But there is a logical rank order. So Anne-Marie, out of your delicious breakfast, what component of it do you enjoy the most? Is it your tea, your orange juice, your wheat bread, or your egg?
My decaf tea.
Your decaf tea. So for Anne-Marie, her rank would put the tea number 1. Her ordinal order would be tea, decaf tea, number 1. I almost forgot that. Would certainly be number 1. Or I could even have asked her a question like this, where a good example of ordinal variables you can use with a qualitative survey like, Anne-Marie, for your breakfast, were you extremely dissatisfied, neither, satisfied, or extremely satisfied? Now, this would be a weird one since I think she made it herself. Extremely dissatisfied, she could fire the chef, but the chef's free. So anyway, so ordinal, we're creating an order, we're creating a logical ranking, but it's not something that can be measured. It's not a numerical measurement. So that's what we mean by ordinal. So you can, by the way, this gets into kind of taking qualitative analytics and making them more quantitative, something you can count. I could, if I were surveying people on how happy they are with their breakfast, I could give them a survey where 1 equals they're never happy, 2 is sometimes, 3 is oftentimes, 4 is always. And if I survey enough people where it's statistically relevant, we could actually have a pretty good analytic on how satisfied people are with their breakfast by making this ordinal qualitative variables and converting them into a quantitative variable, something with a measurement. All right. Again, I love little tricky learning points. Ordinal, think order. Easiest way to remember. All right. That is all for qualitative variables. Now, let's head into quantitative, something we can count and can be aggregated. And there's really 2 kinds of data that we deal with when we're looking at building analytics with something measurable, something that has discrete variables, and something that has continuous variables. So let's take a look at it. When we're talking about a discrete variable, this is numeric data that can only be counted, but we can't measure it or divide. That's weird. Wait, we can count it, but we can't measure it or divide? That's true. So I'll give an example of this. Characteristics of discrete data. Data can be counted. It's usually an integer, meaning, I hate to use these math terms because I know not everybody, I actually did enjoy math. I actually did very well in my math classes. But anyway, it's a number without a fractional component. That's all an integer is, whole number. It cannot be measured. So your weight is not a discrete variable. Why? Because you can get on the scale like I did earlier this morning, look down and get the measurement and say, yes, I'm doing pretty well, or maybe I need to watch how much I'm eating that night. I did well this memory, just for the absolute record. Anyway, also, when we look at a discrete variable, so weight is not discrete since it can be measured. A discrete variable also can't be divided into smaller pieces. So let me give an example. If we ask somebody, hey, how many children are in your family? You can't divide that number. It's a whole number. You can't have half a child. Now, I know plenty of adults who might qualify as half a child, but that's a completely different discussion for a completely different day. But you can't, it's a whole number. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 children, whatever the number is, but you can't have 2.5 children. Also, when we look at a discrete variable, it has a limited number of possible values, like months in a year. Newsflash, there are 12 months in the year. That's it. We cannot have more than 12 in any analysis we do. For a particular year, only 12. All right. Examples, here's just some examples of discrete variables, things that you can count, but they're discrete. Number of children in a family, number of students in a class, number of loans that are in default, number of touchdowns in a football game, whatever the case may be. Which in that last one, we know Philadelphia needed 1 more touchdown in that Super Bowl.
Yes, they did.
Born and raised in Philadelphia. That was maybe a little bit of a painful analogy that I gave, but
actually I expected it.
Really, because
yes.
Both good teams.
No, I expected you to make that analogy. They were both very good teams. It was a game that could have been measured slightly differently.
Yes, no doubt. But these are good examples of discrete variables. So learning point. Things, anytime you're looking to do an analytic with discrete variables, look at histograms and pie charts. They're fantastic for displaying discrete variables. And because not all visualizations are great for every analysis. All right, let's continue. So next thing, continuous variables. So we've done the discrete. What's a continuous variable? Probably, as you can all figure out, it's a variable that can be meaningfully divided into finer levels. It can be measured on a scale or a continuum, and it can have almost any numerical value. For example, if you measure a person's height with very precise scales, you can get to feet, inches, percentages of inches, meters, centimeters, millimeters. I don't know if we have some international folks here, but I could tell you meters, centimeters. I'm lost. I'm absolutely lost. In America, we use feet and inches. I know those pretty well. It can take, when you have a continuous variable, it can take almost any value between two numbers. So I mentioned, if you weigh yourself, let's suppose you have your weight is somewhere between 100 and 150 pounds. There are literally millions of possible heights in between those weights, as I show in my little example here. By the way, my scale not nearly that precise. Anyway, when we're looking at continuous variables and we want to present those in an analytic, histograms, once again, tend to show up. Line graphs are often used too. Those are both really nice techniques. All right. Next thing I want to bring up out of this whole presentation. If you want to keep all this stuff straight, just print this slide, put it up in your office, and it'll tell you what you need to know. When we talk about data variables in a quantitative analysis or qualitative, nominal, ordinal, named, order. Quantitative, discrete, or continuous. This one slide sums up everything I said on those four types of variables that we could use in our analytic. And when you're building your analytics, this is the stuff you got to be thinking about. When I meet with a business person and they talk to me about, hey, we want to really look at our service level. Like, we want to understand, are our customers satisfied with our service? Well, number one, coming off the get-go, is that something that we can measure, like number of products shipped or height? No, it immediately begins as something qualitative. Okay, so if it's going to be qualitative, what I would probably look to do, and Anne-Marie, you'd probably look to do this too, it's certainly the advice you gave me on my dissertation, is how do you take something that's qualitative, that we do want to get some level of measurement for, and make it into something more quantitative? And in this kind of case, it would probably be a voice of the customer type of survey. Maybe, first off, if we want to understand how satisfied our customers are, first question is, which customers? So I'll give you an example. I have two manufacturing client partners I'm working with today. One, basically 70–80% of their business are 5 customers. The other one, if you took their top 10 customers, they're not even 5%, they're only about 5% of their business. Completely different customer not prototype, but
Profiles?
Profile, thank you. That was the exact word I was looking for. 2 different kinds of customer profiles. So if I'm looking to do an analysis on the first company, I probably want to either do one just on those massive strategic accounts, or maybe my analysis should be on why we're not getting more business from the smaller ones. So those kind of things, which we would have to answer those questions, and then take that qualitative analysis, build a survey. What we probably do is use it where it would be some kind of order. How satisfied are you with our service? Always satisfied, somewhat satisfied, those kind of things, and really try to do a survey first so that we could start building a good analytic on how satisfied are our customers. So hopefully that makes sense.
Mm-hmm.
Any questions before I move forward and so to get to hypothesis testing?
Actually, we have a question. Can David please describe what nominal means again?
I absolutely can. Nominal means named. So if I need to do an analytic on vegetables, Or let's take something more fun, meat, right? We all like that. Right? I know the Marco household does. So, you know, if I want to do a study on meat, meat is something named, whether it's beef, bison, pork, chicken, these are names of things. So nominal, think named. Whatever study we're doing, whatever analytic we're doing it on something named. So I hope that that makes sense. So product categories. So I used a very generic, let me do something that probably applies to everybody here. Product categories, customer types. Those would all be things that we name. So if I want to do a study on customer types, we're starting with nominal variables or named customer types, 1, 2, 3, strategic, line, whatever you're calling your customers.
And David, to do that, you need to have consensus on what your product types are, what your customer types are, how discrete you want to make those different types of products or customers. And from there, you can decide how much of those you want to be able to measure. Do we want to measure different types of property insurance, which could get very discrete, or do we just want to look at property insurance versus casualty insurance versus life insurance, those three big categories? And we have to decide that and come to a consensus before you can go farther down that nominal path. Am I right?
Anne-Marie, of course you're right. And really what Anne-Marie's bringing up, a topic near and dear to our hearts, is the data governance around these concepts. Because to say that, oh, we have 10 types of customers or 10 types of products, most companies have not really defined those. A lot of the folks that we've seen and that we've worked with over the years, companies don't really know what that is. They go, oh, well, we have strategic accounts. Who are they? And then they'll name accounts, but they don't actually have criteria for those accounts. And when you do this correctly, you need to have great governance around these, where you have defined what types of customers do we have? What are they? What do they mean? Same with products. My goodness, I mentioned manufacturing before. Most manufacturing companies have far too many product hierarchies because really they almost do them by department, which is not a real hierarchy that you can span across the enterprise. And you see it when you work with a more sophisticated manufacturing company. You see the difference of this on the shop floor. You absolutely do, of how organized it is. So Anne-Marie, I completely agree with you. You're exactly correct. Having those clear definitions, understanding exactly what we mean, and limiting your analysis, because some of these analysis, if you group everybody in it really won't give you what you need. Kind of my example where the manufacturer has really 5 customers who account for 70% of their business, but they have thousands of total customers. If we do analysis on the thousands, that's going to give us a very slanted view compared to those 5 strategic accounts, which are 70% of the business. Probably we should handle those guys a little bit differently. What do you think, Anne-Marie?
David, I would agree. And those thousands of other customers for this particular client and many others that are just grouped into non-strategic, well, that's not a great grouping because it's too broad.
That's
How
right.
do we break that group down to make it more discrete and at the same time meaningful for analysis for this client to get the data that they need to make decisions that they want to make or need to make?
That's right. I'll give you just another example, just pops off the top of my head. Let's suppose we were selling a product that, you know, is ubiquitous, the kind of thing everybody purchases, toothpaste, soap, something like that. And we said, hey, we want to increase sales of our product, whatever it might be. And we were to do a study, hey, what do people watch? What kind of advertisements do they see? And we would find maybe, you know, different things, like maybe, let's say we make a decision that we want to sell primarily to a younger audience, maybe 20 or less, or 25 and younger. And we just look at all people who we sell to, and we look at the media they consume in the ads, and we find out the number one thing are emails they receive or ads they see on television. Well, I could tell you if we're trying to reach that younger demographic, we've missed the top two, because the top two are probably TikTok and why am I blanking on the other one?
Instagram.
Yeah, those are two of the really popular ones. And so we've biased our analysis because our real goal is to meet a younger audience, but we didn't limit our population. So that would be a flawed analysis.
Now, we have a question, David, that plays right into your last statement. How do you address bias in this type of analysis?
Oh, is that a great question? So we probably need to do a separate webinar on bias. I just did a webinar on bias 2 to 3 weeks ago. So bias, so Anne Marie, in answering that, I just want to spend an hour talking about bias. But let me start at let me just get a couple of high points, and we'll definitely do one on bias. Number one, all analyses you're doing have bias in them. Mm-hmm. All of them, universally. This is something Anne Marie taught me in my dissertation work. Bias always exists. So the first thing you have to do, to me, when I'm looking to build an analytic, so take a step back. If we just need to know how many widgets we're making today, I probably don't need a bias analysis. Let's just spit out a report. It's pretty cookie cutter. But for something a little bit more involved, something where we're going to make decisions, any analytic you build should have a plan to mitigate bias, much like you do, again, in academic rigor. Admit it's there, create a plan to deal with it. For example, there's, I think, about 30 forms of bias. I forget how many I walked through in it. And again, we'll do a webinar on this topic. What I like to do is say, okay, what kind of bias are we most could be guilty of here? What are the most obvious ones? So if I'm asking a salesperson of strategic accounts to tell me, hey, where do I find the key data? Well, I know the person I'm speaking to has a bias because he or she deals with strategic accounts. So I need to find some other people who deal with the non-strategic accounts. And I need to map out, where do I think bias is most likely? And then I need an action plan to go against it. And the first person you have to look at in bias is in the mirror. Mm-hmm. If I'm building a report on a topic that I'm driving, there is bias in it by the very definition of it. If I believe that when it's warmer outside, people are more likely to consume ice cream, the very hypothesis I just gave you has a bias in it. I like ice cream. Ice cream's delicious on a hot summer day. So I have already, in my beginning hypothesis, created a bias. And those are the kind of things that you want to avoid. So number one, admit it's going to be there. Number two, how do you plan on circumventing it? And that is something that if you really put your mind to it, there's some clever things that you can do. And Anne Marie mentioned about academic rigor. There are books on this topic that people deal with in dissertational studies that we can actually leverage in the real world. Mm-hmm. Things like triangulation is a great way to deal with bias. Meaning, if I'm trying to prove a hypothesis, this is a perfect concept to go into hypothesis testing. If I do 3 types of analysis for a hypothesis and I get the same answer using 3 different methods, that's called triangulation. We're probably right on target then if we got the same answer.
Right.
So let's look at but great question on bias. All right, let's hit. So I'm sorry, so for you aspiring data scientists, here will be some concepts for you. When we look at hypothesis testing, so first up, this is different than just a report. Hey, Anne Marie needs to make sure the shelves are stocked. She gets a report saying shelf B needs 20 widgets. Very simple. That's not a hypothesis testing analysis. That is not data science. It's a to-do list on a report. She looks at it. picks up 20. She would juggle them all with both arms, which is a very entertaining sight. Would go to a shelf, lower shelf probably, and then put all this stuff into the shelf. So that's not hypothesis testing. Hypothesis testing is when a tentative explanation for something you're observing or a phenomenon or a scientific problem, we can test it by further investigation. Oh goodness, a simpler way of saying it is I'm making an assumption. I'm making an assumption.
You're making an assumption.
And some of the best analytics we've seen over our career come from just people taking a guess, like saying, hey, I think I see something in this data. And let me create an assumption, create a hypothesis, and then let's test it. And when we talk about hypothesis testing, that's just the formal procedures we use to test whether we can accept the hypothesis or not. So we need to use data from a sample to draw conclusions. So when we talk about a sample of a population, oh goodness, that sounds so technical, but really it's pretty simple. If I want to understand how many people eat an apple every day in the state of Illinois, well, do I need to get a population of people outside of Illinois? No, we're only looking at the state of Illinois. Do I need to survey everybody? Well, I would love to, but that would be incredibly expensive to do. So we need to get a sample, something statistically relevant. Anytime you see a statistic on a website, in a newspaper, in a magazine, first question you should ask, how big was the sample size? I mean, if they have 10, 20 people, probably not that relevant, unless it is something that doesn't have a big sample size, something that you can't get to 50 and 40 and 100 based on what it's doing. Sometimes hypothesis testing is called educated guessing, and there is a level of that. When we use the word inference, this is the process of drawing a conclusion about a population. Think sample of data. You know, that's all it really is. So typically, again, you can't do the whole population. What's a null hypothesis? This assumes there's no statistical importance between two variables. So in my hypothesis that the warmer the weather out, the more ice cream people are going to eat, the null hypothesis says that it's the opposite of what the hypothesis. It says no, when the temperature goes up, ice cream consumption does not go up. And anytime you are doing an analysis, some type of hypothesis testing, you assume the null is correct. So you talk about getting rid of bias, that's one way to do it. So if my hypothesis is the hotter it is, the more ice cream people eat, you start your analysis with the null hypothesis, you start with the null hypothesis, you assume it is true, because the data has to prove that it is false, therefore proving the hypothesis.
David?
Yes.
Is one way to test a hypothesis by doing a survey? Are there other ways?
Absolutely, there are. Oh goodness, tons of other ways. Let me bullet a few out. Survey is a great way to do it. Also, you can purchase this data. A lot of third-party providers do this kind of stuff where they gather this data. Something like a Nielsen report, a LexisNexis has all kinds of, in insurance, my goodness, there's almost an infinite number of these kind of folks. In addition, your website could be a source for that. When Amazon does this tons of ways with rankings, again, website, your salespeople asking their opinions. There's all kinds of techniques. You may even be capturing this within one of your applications where you can actually then mine that data. So yes, Amory, there are tons of ways to do it, not just a survey. You could even do interviews. Now, interviews are very expensive. You could do focus groups, ditto on the cost. So if we want to create a new flavor of ice creams, I don't know, I'm stuck on the ice cream topic. I've been using it for a little bit. I'll just stay with it. We want to have a new flavor of ice cream, passion fruit. We want to see if people like it. It could be something where we do a survey group. We bring in a group of people, we serve them the passion fruit ice cream, and then we have a discussion what they thought. those are all different techniques and more than that. But interviews, focus groups, those are going to be much more expensive when you talk about data collection.
Thank you.
All right. Hypothesis testing, as I've said, begins with the creation of a null and an alternative hypothesis. So let's say our null hypothesis is that a compound, think medication, a drug, will not impact health outcomes. It proposes that those who receive the treatment will not have any positive difference in their outcomes. The alternative means is that there will be a difference. So I think I've really explained this. So if we were working at a pharmaceutical company and we create a new compound, drug, the way it has to be tested is a null hypothesis, saying this thing isn't going to do a damn thing. That has to be the starting place, because the data must prove that it makes a difference. Think of this as innocent until proven guilty. This is a great real world example. If you have committed a crime or are alleged to have committed a crime and you go to court, the default position is you're innocent. And unless we have a preponderance of evidence that a reasonable person, which would be a jury of your peers, thinks you're guilty, then you're not guilty. That's your starting position. Same thing here. If we're doing A and B testing on a drug, the null hypothesis should be the ruling one to begin with. This thing will do nothing of value. That should be the null. And unless the data proves otherwise, that's the position we start at. So I think I give a little example is if a group that received the medication had 2% improved health outcome as compared to a placebo group, which in drug testing, that is the gold standard, actual versus placebo, blind, double blind. That's the gold standard. We may, with only a 2% difference, conclude statistically, this is not enough of a difference to say that this drug has any value. And 2% would not be a statistical difference unless you had a massive, massive study. It's too small. There are too many variables, unknown variables that can impact it. All right. Hypothesis testing. Now, we've spoken about that, and I'm going to really end with just a couple slides on correlation. So let's talk about correlation. Correlation is a technique that can show whether and how strong pairs of quantitative variables. Quantitative. Everybody in our audience just shouted out quantitative. Quantity, it means we can count them. Yes. You all get a gold star. Just an absolute gold star. You can pin it on your lapel right now, or shirt, or hoodie, if that's what you're wearing today. Correlation. Correlation is limited between a -1 and a 1 and everything in between. When we say something has a correlation of -1, it means the two variables we're comparing are perfectly negatively correlated. So it means if one variable is moving in one direction, the other one is moving in the opposite direction perfectly. So if I'm trying to think of an example of this
David, how's this one?
Please.
As the weather gets warmer, the consumption rate of ice cream goes down.
Yes, that would be negative, assuming that it actually does go up. That maybe it's going up. I was trying to think of an absolute one, Anne-Marie, like
okay.
People who buy one car don't buy a second car, something like that. I was trying to think of something where, like, if you buy one house, your probability of buying another house is negatively correlated. Something where you would only buy, would only do one, and you're always going opposite. So as the weather rises in temperature, if we wanted to show ice cream consumption went down or went down, we would end up finding it goes up. We would probably have a negative correlation. When something is measured out at 0, it means that the variables do not have any correlation. That when one variable moves one way, the other one can move in any direction. We don't see any correlation. And again, remember, you can have many numbers in between these. Between a 0 and a -1, you could have 0.00487, as a negative. You could have any number. And then a correlation of 1, it means the variables are known to be perfectly positively correlated. It's perfect. That is, one variable moves up, the other one moves up in relationship to how the first variable moved. So they are both moving in positive directions. They always move together positively. All right, let's give an example, shall we? Let's suppose we study the correlation. This kind of an analytics that we build. This is the kind of stuff organizations need in order to be data driven. That's what all this is about. Suppose we study the correlation between an individual's average income and the revenues of two companies. Let's pick Chick-fil-A and Hobby Lobby. Our hypothesis is that a person's income, the greater, is that the higher a person's income, the greater the revenues that these two companies experience. And if we were to gather some sample data for this that we think would be appropriate, we can analyze it, and we may find that Chick-fil-A has a correlation coefficient for this hypothesis of 0.07. Well, what does that mean? It just means that as we see people's incomes rising, we're really not seeing them go to Chick-fil-A any more than they would normally go. That a person of a higher income level doesn't go to Chick-fil-A any more than a person of a lower income level. And 0.07, pretty low. I would say that there's not a whole lot of correlation there for our hypothesis. Hobby Lobby, though, maybe we would do this analysis and we'd find that it's 0.81. Now that's extremely high. That means that as a person's income goes up, they're spending much more money at Hobby Lobby as compared to somebody at a lower income bracket. And I've just made up these numbers. So don't, if you work at one of these organizations, I'm not giving away any analysis. We could see that both companies are positively correlated to a person's income. However, the Hobby Lobby correlation is much, much higher. That's what we see. Makes sense? Correlation. This is what we're measuring. It's a number between -1 and +1, with 0 being no correlation, +1 being perfectly correlated, -1 perfect negative correlation. All right. We're almost done. Oh, and I better speed it up. Correlation, the big thing you want to learn, correlation does not always equal causality. Good example here. Real statistic, Anne-Marie, you ready for this one?
Yes.
100% of adults who have died in the past year have eaten an apple at some point in their life. That is a perfect correlation coefficient of 1. Perfect, Anne-Marie. Apple, we can 100% with certitude say apples cause death.
Not quite.
Nope. But we have a perfect correlation coefficient, right? Literally, everybody who's died, who's an adult, has eaten an apple. That's perfect. But what's missing? Correlation tells us how strongly a pair of quantitative, meaning you can count them, variables are linearly related, but it doesn't explain the how or why. That's the issue. Because it turns out the consumption of apples and the number of people who passed away in a year who are deceased are not related to one another. There's actually no relation. Let's look at something a little better. And I show that. Those of you who've been in our webinars know I love this example, because just because two variables have perfect correlation, it doesn't mean that we have causality. Give a different example. Suppose we're looking at the sales of air conditioners and we want to correlate them to the sales of sunscreen, meaning, are people buying air conditioners because they bought sunscreen or vice versa? Well, no. The cause of both purchases is something else. So the fact that I buy an air conditioner, that doesn't motivate me to buy sunscreen. There's something else happening, and probably in this analysis, it's hot weather. Now, I'm using very clear, easy to see examples. In the real world, these are not as easy to see. In the real world, the differences between why somebody buys products in category B and your products in category C is much more nuanced, much more clinical in how you have to analyze that data to come up with really some understanding of what is driving purchases. Establishing. Oh, I'm sorry, Marie.
I'm sorry, go right ahead. I'm sorry, I thought you were finished.
Oh, no problem. One more line and then hit me with your best shot. Learning point. Establishing that one thing causes another, real data science. It takes a very detailed, methodical, and unbiased approach. It's difficult. Anne-Marie, hit me with it.
The reason I jumped in was that we have a question very appropriate for this particular point. What happens when the analyst has intuitive knowledge of the subject being studied? Is there an issue here with that? Does that have an effect on the way the hypothesis is written? What would you say to answer that question?
Really outstanding question. And it does have a big impact. And it's one where we would have to ask ourselves, what is it that we are trying to hypothesize on? So if we are trying to hypothesize on something that's better known, which right off the get-go, you have to ask yourself a question, why are we hypothesizing on something we already know about? Right off the get-go. So to me, I think it's critical having that third party mind where somebody can come in and just say, hey, this is already biased right from the get-go. You have already made an assumption right in your hypothesis that will skew our results. Even the data you're collecting, skewed results. And there's an old saying in statistics. There are there are numbers, there are statistics. Oh, I'm sorry. There are lies, there are damn lies, and then there are statistics. And there really is some truth to that. It's an old saying. It took me a while to pull it out of my archival memory. But I don't know if you saw the tape deck world there. The old days. But it's a really good point. I can create a statistic that can prove anything you want. Absolutely anything you want, if we put in enough bias and slant it enough. That's why actually this is a totally different topic when we get into bias. That's why I think critical thinking is probably even more important today than what it was before. One of the jokes I like to give people is, hey, I read it on a website, it's got to be true. So having that critical mind is vital. So whoever asked this question, it's a really good one. I would absolutely want somebody who is skilled at knowing how to combat bias, how to combat putting bias within the analyses, and really using some of the more tried and true methods of countering bias. For example, if I'm going to interview customers as part of a survey mechanism, if I know all these people very well, I've worked with them a long time, I'm the wrong person to be the interviewer. Maybe I want Anne-Marie, somebody who's never met them, be in front of them and ask, and now that conversation can go in many different directions, rather than myself who already has a built-in bias. There are all kinds of techniques to combat bias, knowing that at the end of it, you're still going to have a little bit in your analysis, but at least you built your plan, especially in data science where you're hypothesis testing. I think that's really important.
And David, isn't it important to have the hypothesis written by somebody who really needs to delve into this question rather than somebody who intuitively knows the subject?
Yeah, in fact, I would say the person who intuitively knows it is bringing so much bias to the table. Just to your point, and you and I have experienced this many, many, many times in whether it's analytics that we're building out or something else. And it's really one of the great advantages being a consultant is that we don't really walk in with a whole lot of biases. I haven't worked with the people, for any period of time, normally. So I completely agree with you. That could come in, and especially if you're just trying to prove what you believe, again, you'll find data sets that could convince you of whatever it is you want. If you just bias them heavily enough, you start calling them outliers and you throw them out and you'll end up getting the results you want. But that's
Mhm.
not, it's heavily flawed. All right, speaking of analysis, let me get to the final analysis. Qualitative and quantitative analysis techniques differ. That's why I walked you through the difference in even the data that you're using. Make sure you understand what you're doing and make sure you're using the proper techniques. If you're doing quantitative analysis, very different than qualitative. Remember, correlation does not always equal causality. Many times it does, but not always. And make a plan to remove bias from your analytics. They exist, they're very prevalent, and if you don't have a plan to defeat it, it will bite you and prevent you from being data-driven. That's what you don't want to have happen. With that, Anne-Marie, I saved you all of 2 minutes.
Thank you, David.
Any questions that we can go after, or should I stop sharing and have you bring us
We've
on?
answered all the questions that have been posed right now, but please remember that datamanagementu.com and David are available to answer questions subsequently. Datamanagementu.com on LinkedIn, great place to post questions, write comments on the topic, see what your peers think. That's great for everybody who is signing up from this webinar to follow Data Management U on LinkedIn. We will be back with another webinar, March 30th. Malcolm Hawker, a world-known expert on metadata management and master data management, will be talking about how to develop a master data management plan and launch a successful one in about 3 to 4 months. This is an interesting webinar, and we hope you'll all register and join us March 30th, last Thursday in the month, same time, same channel. And right now, I'd like to thank EW Solutions and David Marco, our darling presenter. And I wish you all a great rest of your day. See you in a month.
Take care, everybody.